Hello everyone. During this lesson, we will explore the fundamental concepts of object-oriented programming. Specifically, we will delve into inheritance, polymorphism, as well as encapsulation. First, let's explore the concept of inheritance. Inheritance is one of the most important concepts in OOP, and it tells us that any class can have a subclass that inherits absolutely everything from the parent class. In other words, from the superclass. Let's now create a base class together, as well as an additional class that will inherit everything. Let's imagine that our base class will describe all structures, so I'll name it building. In this class, we will include only common characteristics. Every structure should have a year of construction, initially set to none, and a city where the structure was built. Optionally, you can add as many fields as you like, but for now, we'll limit ourselves to these two characteristics. I also want to add a constructor here. It will take two parameters, the year and the city. Below, we will simply refer to specific fields, such as the year, and set the value obtained from the constructor. We will also refer to the city and, again, take the value from the constructor. In addition to this, let's create another method named getInfo, which will simply display some information about the specific building. For instance, I will refer to the year to display it and also print the city where the building is located. To do this, we access self.city. In general, that's all we'll add to this class for now. At the moment, we've simply described a class that represents a structure. Based on this class, we can create certain objects. For example, I want to create an object called school, which will be based on the building class. Inside, I will pass certain characteristics. Let's say it will be the year 2000 in the city Boston. All of this will work correctly, of course, but let's imagine a situation where in the future I want to create another object that will describe a specific house, as well as another new object that will represent a store, and so on. It seems like everything will be handled correctly, they will all have the same common characteristics and methods, but suppose that for the school, I need to add a few new functions, and a little later, a few more new functions for regular houses. For this, I would have to specify all these functions above every time. As a result, one of my classes would have a lot of additional functions. It would all work correctly, but reading and understanding such code would not be very pleasant and clear. Therefore, it would be much more logical to create additional subclass classes. In each of these three classes, we will have our own functions and fields. Thus, we will not clutter the common class with unnecessary information. Instead, we create new classes that inherit everything common from the base class and complement this common functionality with their own unique functionality. So let's try to implement this now. Firstly, let's hide the building class so that it doesn't interfere with us here, and then we'll create a new class named school. Here, I open parentheses and indicate that I inherit everything from a class called building. If we don't write anything inside and simply use the keyword pass, which means that we have nothing in this class, I can easily create an object based on the school class. Easily pass some parameters there, and even if I run it now, I won't see any errors. Additionally, through this object, we have access to absolutely all the characteristics that we created in the base class. So, I can comfortably access either the year of construction or the getInfo method. If I run this, everything will be processed without any errors because I inherit everything from our defined class. Thus, all common characteristics will be recorded in the building class, while all additional characteristics belonging to specific buildings will be recorded in their respective classes. Following the same analogy, we can create another class called house as well as store. Now, I can do the following. House will be created based on the house class, and store will be based on the store class. Again, if I run all of this, it will be processed correctly. But now, when I need to add additional functionality, let's say only for the store, I won't write it in our base class. Instead, I'll write it in the additional class called store. Now let's try to write something additional and interact with all of this. I suggest working with the school class, but you can perform similar actions with any other classes. Here, I want to specify a characteristic called students and set its initial value to 0. Again, this characteristic is not needed in the house and store classes because the number of students can only be in a school. Additionally, I want to define a constructor. In it, I want to receive the number of students as well as the values that I will subsequently pass to the constructor of the parent class. Therefore, here I will specify that I want to receive the year of construction and the city. Next, I want to do the following. For students, I want to set the value obtained from the constructor, and I also want to pass data to the class constructor. To do this, we need to call a function called super. It calls the parent class. Inside, we should specify a few characteristics. First, we should specify our class through which we are calling all this. In my case, it's the school. Also, we need to pass the self parameter. Then, we put a dot and refer to the necessary method. In my case, I refer to the constructor from the parent class. Inside, I specify that I pass the year and the city. Now, at the end of the program, we should pass one more additional parameter. Let's specify that we will have 100 students in the school. And if I run this, everything will be processed correctly. And one more point. In Python, you cannot specify that one class will contain two parent classes simultaneously. That is, here, I cannot put a comma and specify another parent class. This will be considered an error. In C++, there is a concept called multiple inheritance. It was criticized for confusing programmers. Consequently, in languages that emerged after C++, this feature was removed, and in Python, there is no multiple inheritance. Now let's consider another concept of OOP polymorphism. Thanks to this concept, we can override methods declared in the parent class, and we can override them in subclasses. Suppose our method getInfo works fine in the house class as well as in the store class. It works well here because in these two classes, there are no additional characteristics. If I try to call this method at the end of the program, the method will output all the information regarding that specific object. However, if we talk about objects based on the school class, the getInfo method doesn't work quite correctly because it only displays the year and city of construction and doesn't display information about the number of students. Therefore, let's use this concept, and in the subclass, we will override this method. We just write the exact same method name, and then I'll do the following. I'll use the super function, and from this base class, I'll call the getInfo method, and additionally, we will output information about the number of students. For this, I simply refer to our students field. Now, depending on which object I call, that method will be invoked. And if we run the program, we will see that when we call this method from the school object, all the information about the object is displayed, and additionally, information about the number of students is displayed. And if we call the same method from other classes, only the year and city of construction are displayed. We also have one last concept remaining, which is called encapsulation. It states that any fields existing in a class should be protected. Currently, any fields, constructors, and methods we have do not have any protection. Additionally, our fields should only be accessible through various methods or constructors that exist within the class itself. Encapsulation is an important concept present in many programming languages, but specifically in Python, it is not heavily enforced. Just for future reference, you should know that in OOP, there is a concept called encapsulation, which is essentially data protection. Well, that concludes our lesson. If you enjoyed this video, don't forget to subscribe to the channel to not miss the next lessons. Thank you all for watching. See you soon. Bye.